I guess we can go ahead and get started. It's right about 11:30, and I know we had an extra long break, but hopefully we'll see if anybody else trickles in. So just to frame this discussion a little bit, my name is Vanessa Hurst. I'm a database and analytics engineer for a startup in Manhattan called Paperless Post. We do online stationery, elegant online stationery, so allow you to communicate formally online. What we're talking about today, shrinking a database, we're actually going to have a pretty narrow focus where I'm going to kind of walk you through a case study of a solution that we implemented at Paperless Post. We're going to talk generally about some of the challenges, but then also talk about a specific solution, a little bit of a hack, but really zero in on the specifics of a particular case study. So feel free to ask questions about the specifics, or also to kind of like jump in and ask questions about similar or related issues that we might not be covering specifically in the slides. So Paperless Post, like I said, is an online stationery site. Just to give you an idea of a little bit about what our data is, we have a lot of different content. So a lot of image files, but really we have sort of an area of static information that is all the content cards that can later be customized per user, per event. A lot of our other data revolves around our tracking functionality. So when you send an online invitation, we try to give a lot of feedback to our hosts about whether people have opened their cards, whether they've RSVP'd. We have a lot of options for feedback that guests can give back to the host of an event. So this ends up being a lot of personalized data where we have names, emails, specific comments. We also have an interesting relational structure where we have like a core event, and then it kind of like branches out into a lot of other people and a lot of other data related back from that core parent event. Okay, so I'm starting from the assumption that we're bringing data down from production when we're shrinking these databases, and that's with the goal of accuracy in mind. This is something I have to routinely explain to developers, but even if you have an idea, like a schema is not the same as your actual production data. So you don't really know how your changes, either your migrations or your actual application changes, are really going to work in production given the historical data, and unless you actually use some of that data. So really accuracy is the reason that we're shrinking rather than just sort of going bottom up and faking the data. Freshness is one of the big goals to keep in mind when you're deciding how to do your database shrink, is like what interval do you need it available on, who needs it and when, how do they need that information. Yeah, these are general principles. They should be available regularly, and it should be timely to do the refresh process. But that's going to vary a lot by your business and who your internal users are. Resource limitations generally is obviously the biggest reason to need to shrink the database. Maybe it's physical disk space, but a lot of times it's all those other things that are related to physical disk space, but not necessarily actually just drive space, like not having enough RAM to actually like reload or do processing on data if you were actually running your entire production database's worth of data on another environment. Certainly developer machines cannot handle production loads, so that's another reason for these shrinks. Excuse me, these shrinks. And then the last note has multi-facets, but it's data protection. So we want to maintain accuracy as best as possible, but we also need to limit the spread of sensitive data. Sometimes that's because of external regulations imposed on us, and sometimes it's just internally mitigating risk by being careful with your information. Summary. Okay, so we're going to delve into a case study at Paperless Post. These are some of our requirements. Most of what we're talking about today was actually built for a staging environment, but we ended up using the same Shrunk database, the end result, in developer environments because it ended up extremely fast and appropriate. But basically, we had the notion of I guess the standard that I was given was actually that we wanted to do weekly refreshes, but I wanted to go ahead and make it feasible to do it on a daily basis and make sure that non-technical people and really anybody within the business could make it happen so that I didn't have to make it happen every time. And then I'm going to kind of set up a vocabulary for us to talk about the ways that we might be shrinking data. And here I talk about slices and mutations. I'll kind of like get into those specifics later. So the resources that we happen to have are that our production environment is far more powerful than anything else that we have. And it also has excess capacity for now. It's really OK for us to use the source and kind of like use resources at production. It's a lot more reasonable and a lot smarter than for us to kind of like offload that to all of the different test and development environments. The destination here, I have that it's limited and it often entirely unoptimized. That's more on the developer environment side. A lot of developers have like Postgres right out of the box, and regardless of how powerful their machines are, they're not necessarily ready to do advanced like loading. And so just kind of have to keep that in mind when making the decisions about creating an actual dump that they might be loading. And then development, something that we were trying to keep in mind is that I'm the sole database engineer, database developer at Paperless Post. And so I went into this hoping to find a way to make this a little friendlier to application developers if possible. So that was a goal, may or may not have been achieved. OK, so shrink strategies. These are just some ways that we can look at the versions of production that we might want in other locations. So the most straightforward, obviously, is just a direct copy. You might just do like a complete backup and restore. You might have live replicas of your production environment. Maybe with like less infrastructure, they might be replaying at a slower rate, and that's OK because it's a staging environment. Maybe you have like tolerance for delay. There's also a lot of options. I think John Erdman actually gave a talk at some recent conferences, and I think he'll be giving it again at Postgres EU. Excuse me. In a month or so, where he talks about LVM snapshots. So there's a lot of options for complete copies, and I think they're interesting, but they're relatively straightforward. So we're not going to focus a lot on those. We're going to focus on this super weird case. So slices are just the term that I like to use for select portions of exact data. We'll get into the types of slices later. Mutations are when you're changing that data. So that might be sanitization. You might be anonymizing data. Ideally, you're still using your production source, but there might be ways that kind of help you meet your terms of service, meet external regulations, and other things. We're going to call those mutations when you need to change the data. And then assumptions are what I call the bottom-up building of data. And that's when you're using like seed databases, generating tests, using test data for your environment. I think these are OK for automated testing environment, sort of like continuous integration type testing. But that's very different from your staging environment where you're working with code that's going to go directly to production next. So I think while these have their value, they're just not good enough for staging in most cases. And so that's why we're kind of moving forward with the other shrink options. So we're going to focus on slices and mutations, which are select subsets of exact data and then changes to those data. So a little more terminology. Vertical slice is what I think of as basically just entire units that might make sense more from the database engineering or DBA perspective. I think things like that might be actual, if you think about actual like physical pages or tuples or even wall logs or like certain increments that might be easy to measure, like the portion or the slice that you're taking. But in most cases, they're just not useful or they're not really relevant. Even if you try to do some version of like point-in-time recovery, but on a staging level, it's really not necessarily going to be the slice that is most valuable to you. And so the challenges with vertical slicing are just that it's really hard to make it relevant to you. And you kind of walk down a road of the false notion. You kind of like walk down the road of wanting to have like a target size, or maybe say like, my production database is 100 gigs, and I always want to be taking 10 gigs. And that's just a really dangerous way to think about slicing, because it's really rare that that type of thinking maps back to what's relevant in your application, what's valuable for staging or testing. And so this is just kind of a rough area. But the one sort of like saving grace of this type is that you might be able to include entire tables or entire objects that might be valuable. And within Paperless Post, sorry, I thought I had this slide here. Maybe I moved it around. Within paperless post, we have an easy case for this of entire tables where we have a lot of like static data that is then later related to individual user data or individual usage. So this is a really good example of vertical slicing, where you might be able to take entire tables and it's still a good decision and it's still useful to you at in the end. But I would say vertical slicing in general doesn't usually work that way. Horizontal slicing is far more valuable in terms of users and application level information, but it's a lot more difficult to write and maintain. It can be custom SQL, usually application code generated. Maybe you have enough relations and like strong data integrity and constraints in your database, so you might be able to do it entirely in SQL. But sometimes that would require application code to say, what chunk of information can I get that's actually valuable to me? I know there are a lot of tools that do horizontal slicing on like a randomized basis, which can be cool, but again, it's like the easier it is, the less valuable it is in most cases. So that's why we're going to kind of go into specific ways that you might be able to make it work for your application. OK, so some of the Postgres tools built in that are really great for vertical slicing, which, like I said, usually is only valuable when you're talking about entire objects. So if you have entire objects that are OK to pull down, you might want to use like the pgdump utilities. There's a lot of great options. Like you can include just the data. You can include just the schema. You can get entire tables. This is something that I didn't realize right away from the documentation, but you can select a set of tables within the same pgdump and put them into the same file. You don't have to like concatenate that later. And then you can select some schemas and leave other schemas out, which is pretty cool. With excluding, so this is all controlling at the source. Like you never actually dump the data unless you need it with this vertical slicing approach. And then on the other side of vertical slicing, you can also create like a generic backup and then control at the destination, either per staging or development environments, with your restore command, what exactly you're putting back in that other environment. And so on the restore side, you can only include the data. You can leave out certain indexes or certain other constraints or metadata that you'd like. You have options about tuning. You can exclude privileges. And so there's some options about if you maybe have vastly different requirements for staging or certain developers. Maybe you might want to like leave certain tables out for certain people or certain uses. This is a totally misplaced slide that I was looking for earlier. Sorry about that. So this is static content that makes for a really good use case for vertical slicing. And then we move into the next alternative to slices, which is mutations, what kind of data you might want to change. You might have external regulations where you need to leave data out entirely. I have PCI compliance in here more as an ideal than actual literal PCI compliance, because in most cases that's going to control what you store on your production environment at all. But a lot of times you might want to be taking extra precautions. If you realize that you're in a certain industry where things are risky, you just need to think about that and kind of hold yourself to your own standard about it, rather than waiting to see if somebody comes after you to find out what your data storage practices are. And then some of that blends in a little bit with internal data protection. For paperless post specifically, we have a lot of email addresses. That's not something that we're necessarily, we're an email company, people get that. Nobody's on our backs about it, but it's not necessarily something that we want to put on every environment ever, the entire collection of like personal data that we have. And then, depending on your terms of service, also depending on what external APIs you might use, sometimes they have terms of service or regulations about how long you can keep information. So you may have that kind of data or like the time regulations enforced in your production environment. But if you're copying it down to other environments, you might be inadvertently violating those terms of service or those requirements. So by shrinking your data, you're kind of like opening yourself up to make the changes that you need to make and be a little bit more responsible. So this is an example of data that we're going to want to do mutations for. It's highly personal, and we don't necessarily want it on, or we don't want our entire production data's worth on staging or especially on developer environments. So basically the solution that we ended up having in terms of these slices is a composite slice using a bunch of these different techniques. So we have a vertical slice where we're looking at the entire application object schema. We're definitely copying our entire DDL, like everything. Excuse me. We definitely want the shape of everything that's on production. The only whole content that we want to pull down is that static content, those cards that I was telling you about. There's also a lot of associated content that powers how things are displayed, and a few other features custom to our site. But we have a very clear set of what is static. It doesn't grow at the same rate as the rest of the application, so it's pretty safe to pull down in an entirety. And then we have a horizontal slice that's going to be a subset of the users and their data, kind of like that tracking data that we were looking at. And then mutation, we have a few different cases for this, but I think the most obvious, like easy to grasp, is the user email addresses, so that later on we can basically prevent staging emails from going to actual users. Which is, I don't know if any, can I see a show of hands if anyone actually got the mint.com email from staging? Did you get 1 or 2 copies? 2. Do you remember? I got 2. That was awkward. Everybody that like manages a database anywhere, I think, was like, that can't happen to me, right? Like, we can't do that. So that's something that was also a really big sell on the business side for how much development this took. They were very clear on that, that being advantageous to change. It also makes your users a lot more comfortable with you. OK, so here's a specific, it's a little smaller than I expected it to be. Sorry about that. But here's just like a specific dump command for how we might start off getting the entire schema from the application. So we're looking at only the default schema. We're getting only the schema, and we're making sure to drop anything that existed before. And we're just starting into a basic slice backup file. Then we're also going to just kind of add on to that all of the static content. So this is something that is pretty cool. I don't know if it's obvious to everyone, but I think it's one of those that you're just sort of like, this should probably work. And then you try it, and it's nice to know that it actually does. You can just concatenate a bunch of these as long as you're careful about exactly what content is in it. So these aren't, I'm dumping the data only this is a specific example table for the cards table from this same public schema, and I'm just appending it onto this backup file. And since I've chosen, schema only for the first dump and data only for the second, there are no conflicts. I'm taking these at the exact same time from the same source. And then we get into the messier part, which is this sort of like horizontal slicing, getting a careful subset of users and their data, and doing the mutation of changing email addresses or really changing any other data that is important to change for your other environments. This is where the hack begins. What we did was just create a new schema, staging. Our application happens to be built in Ruby on Rails, and we're on a version of Rails that doesn't yet support more than one schema. So it's actually, I think it's called security by obscurity, when you just take advantage of the fact that something can't really be done, even if there's nothing about the definition of it that makes it safe or a good idea. So we create another staging, and we know that the application can't touch this data. And then we move into the horizontal slice, where we're doing some custom SQL. Luckily, these sets that we're doing are so small that even though, but we have extra, like I said, we have extra space, we have processing power, we have enough RAM, that this isn't a high-risk thing to do. What we're doing is actually just preserving some of these core data structures with specific logic, and selecting so that we have an actual copy of just the data, obviously in the same structure because we're using select into, but not with the metadata, all of the constraints, all the other things. We don't have to maintain those under this schema. We can just create them this way, and then we continue on to basically dynamically load whatever slice of data that we need. This is obviously a lot of SQL, but if you're someone that writes SQL, it's very straightforward and really quick to go through. The real key to it is just, and one of the big advantages of doing this on the source or like on your production server is that you have obviously you have to be careful with the code, but you're able to do logic relative to the entire data set that you have on production, and also relative to this new slice that you're creating within a schema. And that's really valuable. So in this case, we're kind of like following down the relationship. So this is obviously not actually a table. I hope none of you have tables called stuff either. But this is just like representative, where you can kind of like pull these things relative to this other subset that you've already created. Or perhaps you can get really clever with this. And the really good part of it being in SQL is that you can make it really genuine according to the data, and you can also make it really smart according to your application and like custom to your application. And a lot of the other tools that don't get to this level of specificity they just have no option for that. It has to either be something that's already defined in your application, or you'd have to define a whole new subset of your application. And this really, like this entire thing is really just like one SQL file. It could be broken up if it needed to be, but it's a small slice, like I said. It's really the key is the nature of this logic and how we're able to only get exactly what we need. There are some surprises if you have things like table inheritance implemented. You have to kind of remember that and like build those tables separately, and then make sure like that their inserts are separately. You can't just I wish I had an example of that now that I went ahead and mentioned it. But if for some reason if stuff inherited from users, then you would actually want your select into for users to be from only users, and then you would have to have this stuff separately. Otherwise, later when you try to insert this data, it would not work properly. OK, so we summarized that horizontal slice, some custom SQL that's really cool, but a little verbose in some ways. And now we get into the mutations, which are really just awesome to do in SQL. So I think that was a big decision point for this specific solution, was that, yeah, there are a lot of different ways. Even if those like relationships, those relationship trees might have been a little easier to traverse using application logic, or dynamically using foreign keys if you have all your foreign keys enforced. But doing things like regular expressions over your data is just really fast to do in Postgres, rather than trying to iterate through with whatever your application code is, depending on what it is. And then another good example that we have is cache data. If you have things that are really only relevant to your production environment, you don't want to persist those down. And you're not messing with the accuracy of your data. Sometimes you're protecting your data. In other cases, your application is just not going to work quite right, because you don't want to be like mixing cache between environments. So you just have to kind of be aware of like where you have that kind of cached information. OK, so this is sort of a code summary, just a brief summary of what this basic slice backup looks like. And again, it has the entire schema from the whole, this public schema, so that's the application, the entire tables, the static content. Sorry, this is bouncing. And then we're pulling data only from just this staging schema that we've created a copy of our data in. Sorry, I thought I had another slide there also. So when we go to rebuild this like concatenated file, there are a few other things I'll show you later that end up getting added into this file. But there are a few different strategies that we want to do. We've already made this slice much smaller than the production database, which is really awesome. But we want to keep things in mind like the speed of the rebuild and also uptime. So what I do is actually prepare a new database as the standby, and then I just like close the connections and rotate by rename for our staging environment so that there's very minimal downtime. We recently introduced a connection pooler, so in that case you can actually just do a pause and you don't actually have to have any downtime. But things get better over time. And then this is again a little this is less security by obscurity, but it's a little bit better. We didn't really want our application user to have the ability to do all these things that we were doing. So we took advantage I'd love to hear the Postgres contributors' opinion on whether this is a hack or not, but we made the application user act as a role, so that we created like a new staging build user that was a member of that role, and thus could like assign all objects and kind of preserve how all of the data was assigned to the application user without being that user, and also while having more privileges so that it could conduct this build. And so we're able to kind of like have that separated. And the main benefit of that is that like this build and this sort of like drop and rename databases type of situation is only possible in the staging environment. So it's only possible where we've deliberately made it possible, whereas the rest is actually never changed from exactly the production like privileges and things. So it's a more genuine test because we're able to preserve those, but also enable this only in certain environments. Does that whole role permission thing make sense, or is that really random? Do you have a question? No? Okay. Okay, so we rebuild. We just have basically this this SQL file that we can rebuild just with pSQL. Since this staging schema that we made up has not been created, and we pulled it down as a data-only dump and concatenated it on, it just gets inserted to the tables that have the exact same structure as what it was pulled from when we did that select star into. So all the data loads into the default schema, and everything's happy, and we've totally tricked the application. But now our sequences are wrong. So sequences, I imagine a lot of people are familiar, but just in case, sequences are basically what does auto-incrementing for a primary key in Postgres. So it's kind of like the keeper of a primary key, not from a constraint sense, but it says like, where am I now? What's my next number? What am I incrementing by? And so that metadata gets pulled down with a dump, but since we did a data-only dump, now our sequences are wrong, and when we try to insert new data into the build into the database that we've created from this build, we get sort of like false duplicate data errors. So I wrote another little hacked function that I would love to get feedback on. But basically what this does is goes through and updates the sequences. This is, again, I don't know how good of an idea it is, but it totally works. So like it's kind of a funny little dynamic SQL, but what it does is like the key of it is like get this serial sequence, select set val with this get serial sequence over here I'm using to determine the name of the ID sequence. And so this particular version only works for ID columns, but my application is built with Ruby on Rails, so all of my primary keys are ID columns. So it works out nicely, but obviously you can make this a little bit smarter and a little more custom to a different application. So we basically just now, when you go back to when you're concatenating those vertical slices and the horizontal slice onto your backup, I just go ahead and add this update ID sequences function. It's a PL/PG/SQL, in case that wasn't evident, since I stripped out a bunch of the surrounding data. And then I also incorporate into these functions a vacuum and reindex so that I run that. I basically add the vacuum into this script, and then the reindex, I think, actually runs externally to the script. I totally already explained this already. Basically, we just want to make sure that since we're dropping and renaming and doing all sorts of crazy stuff, that it can't happen anywhere. It should only happen exactly where we've created the user and sort of on the database side made it possible. OK, so this is going back to the requirements for this initial shrinkage and sort of like how I got into this. And that was, we were hoping to preserve daily freshness. This entire build, along with zipping and network copying and actually running a few different versions of it, all takes like under 10 minutes. And so it's like it's happening on a daily basis. It could happen multiple times per day, really whenever. It doesn't even spike load on the production database. It's just like super fast and easy because we're getting a pretty small subset of the user data. We're using both slices and mutations, so we have an area where we're able to decide exactly what we're pulling down, and we can be more flexible with that. Depending on your application, this may or may not be a good default, but for us, data is not included by default. We have two core places where we determine what's going to be included in the slice. And so for the vertical slices, we basically just have like a content file where we're determining like static content and tables, and then we have a little function that generates the actual pgdump command, so getting those exact tables and pulling them in entirety. So that's maintained, and that's really easy for developers to adjust. And then we also have the SQL file where we can add sort of like custom subsets of other data, and it's really nice and reliable in terms of like anticipating the size of these shrinks or these backups, that we don't include things by default. But I mean, that's depending on your application. That might be something that you want to adjust. So the resources, this doesn't hurt us at all. Occasionally it's slow, like the backup is slow on a developer's machine, like I said, because they're unoptimized. But they're usually pretty excited when they read the guide that I gave them about optimizing their environments. And they realize that, you know, once they like get a little working memory and things, they can load it up pretty quickly. This was a little bit of a fail on the DBA resources side, because it does require like maintaining a SQL script when we want to add new data. But we were able through automated rake tasks. We use basically a rake task. It's a Ruby make. It's basically, you know, just a set Ruby script that's like incorporated with the application to build this backup in the first place. And then we use Capistrano as one of our deploy tools, and we've kind of used that to automatically switch the databases. So from that side, it's actually like it's happening probably right now at work, and I'm having nothing to do with it, and that's awesome. But in terms of ongoing development, that's still a questionable area with the big SQL file. So that's the basic gist of things. There are a few more tools that I didn't get to visualize the comparison like I wanted to, but I'm happy to like discuss more with people some of the other things that, you know, weren't necessary for our purposes, but might be appropriate for yours, and tools that I found in the process of like making this work. DBNess is my Twitter handle if you want to like reach out later.
I have a couple questions.
Mm-hmm.
How do you specifically deal with, let's say, stored procedures? And do you essentially use this to generate data for specific unit tests, or is this more for forensic purposes? In your
Interesting question.
In your use case.
So this is actually completely separate from our automated testing, or I guess what I would think of as unit testing environment. So this is all for the sort of like qualitative, like actual people testing. And one of the, I mean, I didn't go into the specific application that we use or the specific logic for what we actually pull down, but we pull our like admin users, and so it's like our QA engineers are able to like create things in the production environment and then see how the exact data that they're familiar with is reflected with the new application or changes to the application. And so by preserving like their exact information, that's really important. So it's definitely a high-touch data environment. I mean, it's also just nice as we've been growing as a company to have simple things like people's username and logins like available on all the staging servers without having to, you know, have them like sign up themselves and things like that. For stored procedures, they're included with that like initial schema dump that I did that was just the structure from the entire production environment. So that's actually how I pull down that update ID sequences function, is that it's been created on production, and then it exists because it's included in that initial dump.
Can you tell us like how big your production database is, how small it is?
Yeah, with the most recent start, it's like 50 gigs for our core application database, and then the slice is about 1 gig. I mean, and there's a lot of flexibility for how much more information we can include, and we played with that a little bit as we've been testing, because like I said, we have like an interesting kind of like relational extension where you have like a person created something, and then there are all the people that they invited to it, and there's also all the things that they have been invited to, and then, you know, so there's kind of like a lot of directions network-wise that you could span out, but we just sort of like set hard limits and make sure that like the team, like mostly the QA engineers, are familiar with what those limits are, so they know what to expect to show up and what shouldn't.
Do you end up having like families of different slices? Like for example, you've got a certain kind of analysis we do. So you end up having, I want this kind of slice versus this kind of slice versus this. You get a lot of requests from developers asking for specifics.
We've definitely, with this core solution, has been able to address a lot of the needs that we had that used to be like that, used to be like a lot of different, because we were able to get just enough information in certain areas. We're still at the point where this backup works for developer environments, but the way that on the back end, sort of like the way that I've modularized things, it'll also be really easy to change and like swap out exactly what subset is created. So we sort of like solved that a lot with this, with a catch-all solution, but later it'll also be easy if it gets to the point where like developer machines can't handle the entire thing and stuff.
Your custom SQL statement to select data from production, are they manually written or generated by some sort of tool?
They are manually written, and honestly, the core reason behind that is because we don't have, not all of our foreign keys are enforced, because it's a Rails application with ORM, so there are some places where we enforce them, and some places where it's not necessarily worth it or necessary, or there are other reasons why we don't, and so it's all custom. Definitely one of the reasons I wish that, like we kind of like chose to do it is because it would be fun to make it dynamic and just kind of like follow trees of relationships down foreign keys. And I think that would be a really cool way to generalize it, but that's not what we needed, so like that's not what I got to write this time, unfortunately. Included in this, I would say we bring down around 30. Some version of around 30, but it's around like 140 that it's out of. We don't bring down any significant. Yeah, there's entire tables. Like this is not a business intelligence purpose at all. So like there's nothing about orders. There's nothing about basically anything slightly financially related. Doesn't get brought down at all.
But if you would like to do a complete QA regression test on a staging environment just before it goes to production,
right,
you have to have a representative of all of the tables in the database. Otherwise, the application may not work.
Yes. Yes. So there are definitely other. I think that kind of addresses his question of like other slices. So there are definitely other slices that we do for other purposes. But this is sort of the general like open distribution version. But we have sort of separate business intelligence backups, and then we also have other ways that we supplement some of that other data.
So somehow between all the different slices, you have to have a superset that will cover all of the database tables like in production. And that is a manual task to see that this is really happening.
I think maybe we could talk about some of the specific, like the specific tables. Some of them matter, and some of them, the nature of them is that it, like they can be ignored. And I know that's like a really dangerous thing to say, but it's like when you're really familiar with it, you can make the decisions on like what needs to be included, what has changed the most over time. For example, definitely always needs to be included, but brand new tables that have only ever seen one schema sometimes like don't need to be included right away. There's kind of a lot of it's just really custom. Cool. Is there a question over here?
Is your schema managed by Rails?
Yes.
Is the actual
Yes.
schema generated by Rails? I find it interesting then that the Rails guys didn't feel compelled to go write their own.
Yeah.
Generate
There actually are some cool tools, but they're not optimized for all of my priorities. So there's actually some, I'm not going to remember it off the top of my head. I think it's somewhere in some of my slides, so I could show it later. But there's a little tool managed by the team at GitHub that allows you to basically pull down relations and it'll like use active record relations to pull down. So you can pull down like a specific user and some things associated with them, and it's really good for, you know, like production debugging, or if you have like a user issue, pull it down to your local. But the scale, like the way that they generate the backup is not something that I would do across the entire application.
Called replicate? Is that what you're talking about?
I think so.
Brian,
Yeah.
that goes.
Yes. Yes. Thank you.
Do you find when using Rails that you have to add extra indexes to the natural key as opposed to the ID?
Yeah, definitely. I mean, there's the natural. We try to make sure that even developers are aware of like.
One is Vanessa, two is Vanessa, three is, so you don't have multiple.
Right, and Rails actually manages that pretty well with like, you know, the upside of like convention over configuration is that there's like really custom naming conventions, and it's pretty easy to kind of like audit what was generated. But one other thing that I didn't include in sort of the PG dump command is that I pull down my schema migrations table, since the schema is managed by Rails. And so that helps that even though every staging server is probably going to be at a very different stage for the schema, there's like a base case of production data that every staging server starts from, and then, you know, you can like apply migrations according to whatever code is on the server. Is that all? Cool. Thank you very much.